Welcome to How to Graph a Regression Equation from Raw Data, Part 3. We begin by clicking on Edit List from the main menu. This brings us to the list editor. Once again, in List 1, we'll want to place the x's, and I'm just going to type in the numbers 1 through 5. Now in List 2, we'll type in the y's. I've selected a problem, and the values are as follows: 1, 32, 243, 1024, 3125. So in list 1 I have my x's, in list 2 I have my y's. I'll click on the menu, I'll go up to regressions, and I'll pick up with the polynomial or power regression. So it asks me where I put my x's. I put them in list 1. It asks me where I put my y's. I put them in list 2. I click calculate, and I see that sixth order polynomial is returned. In fact, it's 0 to the 6th. That would make it a fifth order polynomial. I see that the r squared value is 1. And if I wish to graph this, I click graph, and I see the least squares regression graph here in red. I see the individual data points in white. The r squared value is on the bottom, and the least squares regression equation is given on the top. So this polynomial or power regression works for either one: large polynomials or x raised to a single power. I'd next like to go to the exponential regression using the same data. List 1, where I place the x's, and list 2, where I place the y's. Once again, help is available on all of these screens. I didn't click on the help on the last one, but this is a nice piece of help, I believe. It says that the exponential functions have a horizontal asymptote. So that's something to keep in mind when you're looking at the scatter plot. So I've clicked on calculate, and I see that the equation that's returned is y equals 0.3394 times 7.071 raised to the x. I have a coefficient of determination of 0.9473. I'd like to see this graph, so I'm just going to scroll up just a little bit. Oops, okay. Now I'm going to scroll up a little bit. I'm going to click on graph, and I can see that my model isn't an exact fit. I did miss the data considerably here, it appears. But if you look at the scale, if this is 4.1 and this is 4.6, then this distance from here to here is only a 0.5. So it looks like I really missed it by quite a bit, but actually it's not that far. Although the r squared value tells me that it's not perfect. It's 0.9473. The regression equation is given here at the top, and these white spots are your individual data points, of course. And this ends your session on how to graph a regression equation from raw data, part 3.